Okay, good morning, everybody. This is our virtual session today. And if you've had a class or two with me before, you know how these work on. These days are virtual. I basically do a live screencast of what I would present over in the lab. And for those of you who may not have had a course with me, or just as a good reminder, these workshops really you ought, let me use athletics as a comparison. The workshops are like practices there, and the advantage is that you have these recorded and you can go back and see what I did, and their practice is designed to get you ready to deal with some of the hands-on problems that you'll run into at the end of the course and then in the finals. Now, just as a way of review, take a look up here for a moment, and always as you go into Canvas into the room, it's a good idea first of all to start with announcements, and this is just by way of a quick reminder. And you're always going to see three kinds of announcements. One will be my schedule for that week. Then you'll see invitations to the class sessions, and that's how you join Zoom and join the class session. And then you'll see a recording that I'll post. And of course, that session from Monday has been recorded. You'll always get questions about attendance, and here's the deal. As long as you see the video no later than noon the next day, you're counted as having attended the class. And that means that we're going to have some people who these virtual sessions will probably treat them like an on-demand type of situation. And that's fine. Although, if you're not here in the live feed, you don't get a chance to ask me a question. And each of you do have a chat function where you can ask a question, or if you want, but it doesn't show up on the screen. So if it's something private, that's one thing. If it's something that everybody would probably want to know about, usually I'll just restate that question and go from there. Now, once you've gone through the announcements section, it's obvious the next place you go to, or maybe not obvious, is to go, and this is just some navigation, is to go to the modules. The modules in here are divided chronologically. You may have other faculty who use Canvas and use it use it by topic, but I organize it on week by week because that's what I think kind of drives your thinking is the calendar. And we looked at Nolan Plastics, which is due. Now remember, we will usually be working ahead in terms of cases, and so don't let that throw you. Just look at once we've covered a case, get the thing uploaded, so you've got it there to get the workshop credit. Now, you got a couple, just by way of review, you've got a couple of exams that are coming up on the 8th, which is a Friday. And then you have Nolan Plastics, and that's where we use the goal seek, and we played around with a break-even analysis. And we saw that goal seek was just kind of that really crude as far as the what-if scenario tools. It's just that I set a target value, and then I say, okay, what variable do I change to reach that target value? And so that was a way to kind of put our feet in the water, and also to give us an opportunity to take a look at this whole idea of optimization. What is it all about? To talk about what was in Anderson Chapter 1, management science, and the type of thinking it's intended to promote, and the idea that when we make a decision, the outcomes are on a continuous basis, not a discrete basis. In other words, it's not black or white, it's several shades of gray till you hit a black or a white. And as we think through that, then our analysis of these problems will change. And we talked about that. We walked through the dialog box, and starting with the objective function, and then the cells that were going to be changed, the variables, and then any constraints. And we are working with mathematical models here, and the book talks about the types of models that we use to try to find a way to depict some process that's going on out there in the world. And we also discussed some about the idea that when you use these models, no matter how elegant they are, no matter how sophisticated they are, they're only as good as the data on the ground, meaning the data that you get from your sales records, from performance records, the data that you get from industry standards. And that's why this is such a powerful tool, because what it allows you to do is to focus in on the key parts of a problem or the key parts of some issue or process that you're trying to go through. And it does give you the advantage or the opportunity to rely on heuristics, that is your rule of thumb, and meaning your experience, the amount of time you've been in that industry, etc. So these aren't foolproof. They're not foolproof at all, but they are as best a tool we have to try to say, what will things look like if I do X, Y, and Z? And so the solver lets us do that. Now, I've also mentioned about using randomization. And so I'm going to go ahead and just before we go in, I'm going to come back down here to this Nolan Plastics key. And that's what you should upload here for Nolan Plastics, by the way. I think that's pretty obvious. And I'm going to download this file. And you want to make sure if you're over in the lab or you're on your machine or whatever, wherever, that you have the tool pack. And I'm going to open this up. Okay. And I want to talk a little bit about the use of randomization. Now, your authors don't do that. But here, as you recall, here's our task. We were going to use the goal seek, which is over here. And we click on data. And we come to the what if analysis. And we're going to use goal seek, okay, to obtain the fixed costs necessary to achieve break even. In other words, here. And what does that need to be? Well, the solution's 8,000. And as we played with it some, we saw that as we drove down the fixed cost, the total profit went up. So there's a relationship between the two of them. And fixed costs are also known as sunk costs. They're costs I have to spend. Variable costs, of course, are those costs that are associated with changes in the business. And so the thing that's important for us to remember is that some of these variables are controllable, some of them are not. Fixed costs should be controllable, and the textbook talks about that and walks you through whereby as we make a decision, we're really dealing with the intersection of two data points, what's known and what's unknown, what's controllable and what's not controllable. Fixed costs typically should be controllable because we call them that, and they have that function. They should stay flat. If we were doing a break-even chart, the fixed costs ought to be flat. Total costs should go up as the level of volume goes up, and that's because the variable cost per unit should go up. And then where we look at the intersection of total cost and our revenue tells us whether we're up in a positive region or we're in a negative region. Now, the authors of the text also are going to start to talk about the feasible solution area. And one of the reasons that you hear me harp on the fact that solutions are continuous in nature, not discrete, is that we know, and this is from the algebraic proofs, and the authors go to some trouble to show us those, that there is an area or a boundary whereby we can find we can find a solution. It may not be optimal, but we can find a solution area, and that's the feasible area. But the optimal point is generally going to be either the low point or the high point of where we want to be. Now, I've mentioned this thing of randomization, so I want to take just a moment and talk about it. There are two tools in Excel that we can use to randomize numbers, okay? And one is the equal rand between, okay? And well, I'll just invoke that there. And let's go on the I'm going to click on the insert function because it's going to tell me what this thing will do. And it just says, generate a random number between some set of parameters, the bottom and the top, okay? And then give us, the bottom's the smallest integer, the top is the largest integer, and we're saying, okay, we have a range, and where might it fall within these ranges, okay? What should we expect? And that gives us an opportunity, if we want, to run as many trials. I don't know how many rows you can run in this thing, but we can use the rand between, run those trials and get a summary statistic of some type. We can get a mean, typically. Sometimes people will want to go with a mode if there's clearly one. I tend to go with the average and then try to build standard deviations around that to say that just from strict probability theory that's baked into parametric statistics, that for all intents and purposes, about 2/3 of all the results I get ought to fall within here. And so you can use that to create a ceiling and a floor, a bottom and top, however you choose to do that. And again, they will even give you some help on that. The other is just the simple random function. This is equal rand, okay? And we'll invoke it. We'll take a look here. And this returns a random number greater than or equal to 0 and less than 1, evenly distributed, okay? So this means we're going to get something between 0 and 1, and we just simply go through the trials, and they give us some help on the function and how it operates. So I think we'll use the rand function a few times here. I like the rand between, back a long time ago, when I would work with I was on a team. We do cash flow analysis for mergers and acquisitions. As this tool evolved, as Excel evolved, we were always using the rand between, because we kind of do. We would come up with some estimates of what we thought would be, we would usually, all of us are about 6 or 7 of us on the team, and then a team leader. We would come up with a best case, worst case, base case kind of thing, where base case is what we think will probably happen, most likely to happen in terms of cash flow, best case and worst case. And we would go through and take those figures and then begin to run them on a random basis just to see. typically they were key variables or what we thought were going to be the most sensitive parts of that operation that was going to impact it. We're looking at the free cash flow. So we talked about some of that, and of course, and we've done that, and we also we looked at the break-even volume, and of course a profit goal. Okay, so we're good there. Now today, and I'm going to off if it's going to let me. It's okay. I don't. Oh, yeah, don't want to save it. We're going to go ahead and let me get over here for just a second. I want to mute all. And if somebody's got your got that on, we want to get that off. So I'll close this off. And I don't want to, I'm going to hide that thumbnail. I don't want to take a look at it. Okay, now let's go down and glad to see there are so many, there are 21 of you here. So thank you so much. Glad to have you aboard. Now, let's go back to the modules section. And as I had said, we'll be working ahead. So you've got what you need in terms of Nolan Plastics. I also alerted you to Excel's Easy Solver. That's a website that they walk you through, or a blog. It's a website and they walk you through how to use different functions in Excel. And again, you know, that's one of those things that it's a tool that you can use. And then we talked about GRG nonlinear and evolutionary. Those are assumptions or something that we have about how data points are distributed. And when we worked with Nolan Plastics, we assumed that it's linear, and we were working with a total cost function and doing break-even analysis, which assumes that things tend to be linear. Some things go up as other things go down. Some things go up as other things go up, and some things go down as other things go down. And this would relate to positive and negative correlations, if you will, and then what we would say would be no correlation, where the data points don't cling to any kind of, they don't cling to any type of line of best fit. Well, enough of this, and we moved down there on Monday. I think, if I'm not mistaken, on Monday we also looked at Par Inc. And we talked about the fact that they make golf bags, and they have standard and deluxe models, and all of those issues as they were engaged in what we call load balancing. And I gave you a problem to say, okay, what does the left-hand side of this look like? The right-hand side of this look like if I change the amount of time available? And we saw that we had some components, some work components that had to occur, and a certain amount of time that we had. And so we had to, and I said, okay, if we have 5% less time, how does that look? Well, so we're going to take a look here at M&D Chemical, okay? And I'm going to go back over here to our textbook, and this is the Anderson text. And I'm going to do a little bit of a search here. I'm going to find M&D Chemical. Oh, wait a minute. Oh, I want to search the book. Forget that business. And I want to find it. Search the book. There we go. Not the table of contents. Oh, all right. I know better than that. I know it's there. All right. Let's go over to, let me pop back here for a minute, and it's over on pages 54 to 59. So I'll go back in here. The search function is not being nice to me today, so I'm going to go back over here to the page. There's this, as I've spoken about, the graphical and the feasible solutions area. And they show you those for Power Inc. Let me pop over here to 54. I probably should have just had it pulled up. I've trusted, though, that that this would play nice with me. All right. Now, when we worked with Par Inc., we were working with break-even analysis. So, and we were using the goal sequence. So we weren't really, Nolan Plastics. So we weren't really playing around with setting a goal. But when we did Par Inc., we were maximizing profits. Now this time, the authors said, let's talk about minimization, okay? And so this company, M&D Chemical, they make some type of chemical. They'll give you the background on it. And we start to identify some variables, right? And then we create a linear algebra equation here, and we say, okay, we're going to minimize it. So we're going to have 2 components of A, 3 components of B. We want to minimize those. All right. Then as they walk us through the narrative of building the constraints, and you can see that A must be. We have to make at least 125 gallons of product A. And in terms of the combined, we've got to make 350 gallons. So we write a constraint here at the bottom of this page, and we see that 1A plus 1B has to be equal to or greater than 350. Now, if you see here in the middle of page 55, and let me do something here for just a minute. I want to annotate. I want to get little spotlight thing so you can see. Here's where we are working with the constraints. This is the minimization. This is our objective function right here. And it's subject to these constraints. Okay? And those phones just don't, I'm not even going to bother with answering them. Now, as we go to the next page, and I'll turn that spotlight off. There we go. I thought I got it off. They walk us through a minimum cost solution and give us some more of the details, and then walk us through the algebra of it, and then identify a feasible area or an optimal solution area. And as you can see, the solutions run here and here, and the optimal solution is right here, A250, B100. Now, again, displaying this visually is helpful, and this is one of those instances where I think it's helpful only to the extent that you understand that this is the feasibility area. It's odd looking, okay, and you've got it's a strange type of shape. It's not what we would expect, but we tend to see that when we deal with minimization problems. So we'll move on over, okay? And now we come to an issue of what we call surplus variables. And one of the things we try to do is to identify what we call slack variables or surplus variables. So if we have a slack amount of material, then we want to use it. And if we don't need to use it, then we need to not have it in the process. That's really all there is to it. And so this would be like people who are sitting idle at their desks, who can't work because the computers are down, or a factory where the power goes out because of storms and the line shuts down, or those instances where we're not really fully exploiting the resource that we have. And so the authors walk us through that idea of surplus variables, and then we see, of course, the whole equation right there. right? And the authors walk us through the value of these surplus or slack variables, and we see that there's a surplus or a slack in terms of demand for product A, okay? And that we could it's feasible for us to optimize and not make any of product A. But for practical and marketing considerations, that would be an absurdity for us to even consider it. I'm going to get that spotlight off here for a minute. Okay. Oh, I know how to do that. Forgot. Here we go. All righty. Now, let's pop on over to this next page, and here we see the minimization statement with all of the constraints built in. And the authors give us the narrative. And then, of course, here's that standard where we have the objective function subject to these constraints. And we see the right and the left-hand side of the equations. Now, they're going to walk us through now to the computer solution. And I want to take just a couple of minutes to talk about that. We will spend some more time as we move through the semester looking at the reports that we get, because they'll give us some additional insights in terms of the result we get when we perform an optimization analysis. Now, the textbook, the authors, you're going to see them, they will refer to lingo, L-I-N-G-O, several times. And lingo is a little optimization tool that they've developed, and the authors, and you can go into their lab and you can use it. It adds about $250 to the cost of your text, and I don't see any reason for you to use it if you can do the same thing in Excel, which you already have, and which is what you will probably work on. But you do get a report, okay? And I don't want to spend too much time talking about it, but you will see as we walk through. Here's our optimal objective. This is M&D, the optimal objective value, okay? And then the values for a variable A and B and any cost reductions. Then you see the constraints, okay? And you're going to see a thing called a dual value. And you'll want to explore the text and find out what that is. What it really means is that for every change in a constant, or pardon me, in a constraint, it's the extent to which the gain that we get, it's like, say, marginal revenue. We sell one more product, do we get any additional revenue? And you can also see that for constraint 3, there's a dual value of a -1. The key thing that I'm looking for here is what is there slack or surplus, and we see that on the first constraint, that's the 125, and basically solver's telling us you don't really need to make that. And constraint 2, any change in it adds 4 units of value, whatever those are. Then as you walk through, we see the objective coefficients that should remind you back if you took 1123 with me, where we did that linear regression and we had the coefficients, and that's part of that equation of the line. And so we see the objective coefficient and any allowable increases or decreases, okay? Now, I want you to notice something about the two of these. You'll see this if you have data that are very, very, very close to a true linear fit. Notice that we have an allowable increase of 1 in variable A. We have an infinite allowable decrease. And then if we look at variable B, all right, we have an infinite allowable increase, and we have an allowable decrease. That is, how much can we increase it or decrease it and still stay in the bounds of feasibility. Finally, then we see the constraints, and we see the right-hand side values, the allowable increases, and that gives us a sense of the parameters we're working with, what we can do. And the authors do a good job of talking about alternative optimal solutions, and they do a pretty decent job of walking us through that. Here's the PAR Inc., and you can see that you can see here's the feasible solution area, and you do have alternatives. There's not one particular answer that you have to find. You can see both of these points are at max, and it's not uncommon that you'll have alternate optimal solution. But if you don't have the tool and you're not on the lookout, you won't see it. Sometimes there's some value to graphing these, but frankly, some of the more sophisticated tools you might see out in industry, they'll give you a graphic output as well as numeric outputs. Okay, and the authors will walk us through some terms about infeasibility, feasibility, and this is, I think, self-explanatory. But again, this is why I tell you, decisions, the outcomes of decisions are not binary, they're continuous. And here they give us, they're walking through that problem or issue with the bags. And so here they give us some general linear programming notation, and this is in terms of gallons of products made. And a nice summary. Now, the textbook is their narrative to support you as we talk through these cases. And I do give you quizzes over those chapters just to make sure that you see some of the content, you get aware of it, etc. The more practical aspect is what I'm interested in you hearing and seeing as we work through those. So we're going to we had looked at PAR Inc., and so let's go ahead and we'll take some time here to look at M&D chemicals. Now, remember I provided you a key, and so it's there for you to upload. So I'm going to work on that key, and you'll also see the instructions I put in there, or should have those. I'm going to download it. And we'll take a look at it. Now, here's our solution tab. And let me pop this down for a minute, and I want to see what I had asked us to do. Okay, here we go. And I'm going to put this I'm going to copy this and put this into a text box in the key, which I should have done, but I didn't. But this will work for us. And I'll come back over here. I'm going to insert from a text box. There it is. And then we'll put and let me size it up a little bit so it's easier to see, etc. So go back over here, we'll make it bold. And I'll bold this up a little bit. Okay. All righty. Now, the tasks for this, pretty simple. Find the left-hand side, okay? And the right-hand side, if processing time is increased 19% per product, and at the time available, and let me go back over this because I didn't, is decreased by 8%. So I'll go back over here. Oh, I just needed to make it appear I had copied it. So, a couple of wrinkles here. The first one, if processing time is increased by 19%, what do the left hand and right hand sides look like? If the time available is decreased by 8%, what do they look like? And so we're just basically playing with this processing time as a variable to see how this all configures itself out based on these changes in the processing time. Now, we're looking at the time available, right? And that was, we're looking at time available overall. And when we started the case, we had 600 hours, I guess, or units of time available, and we decreased it by 1%. So I'm sorry, I misstated. I'm looking at the time available, and then we're also looking at processing time per product, okay? So, and you say, well, why would I run into this situation? As I said the other day, this is a load balancing type of situation where maybe you have a new order that's come in, you have a special order, maybe the stuff that was supposed to get there from your supplier hasn't arrived on time. And when you do this, if you use this tool, you can do some contingency planning. And if you're using batch component, if you're a batch producer, batch meaning somebody calls you and says, I need you to make me, I need a 2,000 of some component by, by January. Okay, fair enough. And then I find out that the shipments are running behind. My supplier's running behind. So I have to go back and do a little bit of planning and scrambling around to deal with the time. Or I might be wanting to say, how will this look if I just experiment? So sometimes companies will do an experiment with these types of things, just not in real, but mathematically. So here we've reduced the amount of time available overall by 8%, okay? And then and the processing time is increased per product by is decreased by 8%. So let's look at that, the processing time, okay? And there I did this 90%. Now I increased it by 10%. So let me correct that for just a minute. I'm gonna do that. So that should be 1.08. And it says decreased by, I decreased that. 90% and time available processing is decreased percent and time available is decreased by 8%. Let's look here for a minute. I'm getting myself mixed up. Sorry about that. So I've got the processing time. Oh, for each of those, the time available is decreased by the 8%. I apologize. So I still didn't have it right though. I want to do this. I want to take we'll work back through this for just a second. Okay. And the time, the time available is decreased by process times increased by 19%. And the time available is decreased by, decreased by 8 there. And here I want to increase this by 19%. So this is going to be 1.19. And this should be times 1.19. and the production cost. So we didn't mess with production costs, but again, I guess everybody confused. I'm very sorry. My brain obviously not working. We want to find the left-hand side and the right-hand side of this. If the processing time is increased by 19% per product, that's 19%, and the time available is decreased by 8%. So how would I be in that situation? Well, we've talked about the time available, a rush order or other thing, but this increase the processing time in terms of the products. This may be a quality control issue. Maybe one of our customers has called and said the stuff doesn't work like it should, etc. You just don't know. It could also maybe involve you having to do some different work with your setup to maybe handle a new type of container for the product. Who knows? The textbook gives you a pretty decent narrative, but again, you're trying to attach these values on the basis of the situation. And we're not told to do anything with the production cost, okay? And let's go back up here and we'll start with Solver. And I'm going to click on data. And I'll click on Solver. And we're going to work with B12 and we're going to try to minimize it and we'll run it. We'll solve. Okay, it says Solver can't find a feasible solution for us. Now that can throw you a little bit. You say, oh, wait a minute here. I did what you asked me to do. I increased the processing time 19% per product. I decreased the time available by 8%, but I don't have a feasible solution. Okay? You say, all right, now what do I do? Well, as we'll see when we get into some of these situations where there's not a feasible solution, we'll want to look at the feasibility and feasibility bounds report to get some sense of how much variability I'm playing with. But right off the bat here, what this tells me is that I have, quote unquote, an answer. I just don't have a feasible answer. I don't have one that's within the boundaries of what we would consider feasible. And so we've changed now our situation. We have changed these variables, the time available for process, the time available overall, and then the processing time per product. Now, we're going to go ahead and click on the feasibility. And if you want the feasibility report, okay, I'm going to put my control key down. Here's my cursor. Control key is down. I click feasibility and feasibility bounds, and I'll click OK. And you'll see these feasibility reports pop up. And you'll see that on the total production time, we have no slack time. We've increased it. So we've got a problem there. We violated what would take us to that optimal solution. And the other two, the demand for the products, we have the status for them is binding. So we don't have any slack. We have to make exactly that number of products. Then let's look at the boundaries again. Okay, and this is the second feasibility report. And we'll look to see the cell values. And again, are they binding or not? And we have some boundaries here that we've identified. These two, because we don't have an optimal solution, are going to come out the same. Now, when I'm in this situation, I have what really one of two choices. I can go with the flow and do what I can do, meaning that I'm not going to minimize my total costs, because if I'm not mistaken, as we walk through the so-called quote unquote correct number was a total cost of 800. Here now we've absorbed total cost of 892. So we've got to do something as a manager. Now, if we can live with this, fine. If we have contribution margin large enough on the product that we can absorb this, fine. If not, we're going to have to go back to the drawing board and try to figure out which of these things can we attack the easiest. Can I attack the time available, or can I attack processing time? And that's going to be dependent upon the situation. Or could I try to do some mixture of the two of them to get this down? And obviously, you say, well, hey, you increased processing time per product by 19%. That looks like that's what you should attack. And yeah, on the other hand, the total time available is an issue, and perhaps you could try to affect some type of change with it, okay? But for all intents and purposes, you want to look, if you're going to do the problem solving with this, you want to say, okay, which one's the softer target for all intents and purposes? And the time available for all of this is probably the softer target, because when you start to look at time spent processing these products, this may mean you have to adapt and change equipment. You may have to retrain people, or both. And that may be far easier said than done to deal with that. And you say, well, why? Okay, so why did you give us this 19% change? I also wanted to let you see, using Solver, what we call as a production process out of control. Now, I don't think we don't offer a quality assurance course here. I think in the production course, I would assume that they cover some about quality control and approaches to quality assurance and what that means. And if you took a look at this and from, say, the perspective of Edward Deming, who is the father of quality control, there are three gurus. Duran, I worked with the Duran Institute for a short time as a consultant. There is Crosby, who says quality is fitness of use. And then there is Deming, who says that quality is really a function of the extent to which your product conforms to what it should, conforms to a robust environment. It performs as you expect it to perform. And also that it's within parameters. So when you look at this, a person who studies Deming would say this process is out of control and you need to bring it into control. Maybe, and you're going to have some ways of looking at that. One, I'm going to retrain my employees. Two, I'm going to look at the equipment I have as I process this material and see, do I have the best equipment? Does it need to be recalibrated, worked with, et cetera? And I might also go back to my supplier and say to them, is what, in terms of what you're selling me, you have maybe a higher quality of product so that my processing time could be reduced. Now, just for kicks, let's do this. let's take the, on the processing hours, and we had done that. And instead of 1.19, let's say that it only is going to go up it's going to go up 10%. Or not, let's call it 9%. It's going to go up 10%. Okay. I'll take this back to 10%. Now the time available is kind of an external figure. We're going to assume that that's time available in relation to any other projects that are going on. And now let's say run the solver and see what we get. Okay, let's see if we got an optimal solution there. Solver found a solution. Okay, and it's not exactly what we would expect. The total cost now has gone up. Now, this is an interesting thing because it's saying to us, it's telling us, hey, yeah, even though you reduce the processing time by 8%, the processing time, let's put that into perspective for a moment. We'll take 0.08 and divide it by 1.1, and you'll see what I'm talking about. Okay, in terms of that. So we reduced the processing time, and we got an optimal solution. But that optimal solution is a mathematical solution, not a practical solution for us. we want to minimize when we're trying to minimize total cost, but the cost keeps going up. That tells us that we need to play with some additional variables, and that would be, I might want to say, okay, is there any way on this earth, okay, that I can work with time available? Is there any way on earth that I could work some more with processing time? Is there any way on earth that perhaps I could get production costs per unit lowered? And that's just what we would have to work our way through. And Solver or a tool like this would tell us we got an issue here. Well, folks, listen, it's 11:49. I do appreciate your hanging in here. And thank you so much. Now, again, I'm going to cancel this and close this. And what you need to do, and we'll go back over to the modules, okay? And you have Nolan Plastics, that key that we've got that, so you'll want to upload it, okay? And then we've looked over PAR Inc., and you want to take that and upload it. And then we've had M&D. You'll want to take it and load it up so you get the workshop credit. Now, I would encourage you to say, okay, once I've looked at these, and let me say this, if I'm hoping that you'll have your book and maybe a notepad with you, or you'd have a word pad on your machine and you're taking some notes as I go along. The reason being that as I play around with these, I try to throw some real world types of issues at you, like we just saw a moment ago, where we reduced processing time, but the cost went up. So that's pretty much it now. And of course, today I think I have some, let me look at my schedule just so you can see it real quickly. I'll look at the announcements here for just a moment. And we'll pull down here and take a look at my schedule for this week. And today, of course, is Wednesday the 6th. And we've got the live stream here. And then I have virtual hours today from 2 p.m. to 6 p.m. Okay. Now on Thursday, I've got my back-to-back classes from 12:30 to 3:15, and then 3:30 to 5:30. Those are office hours, and then I have data admin at 6 o'clock, and that's in Shawnee. Now the weather people keep barking at us that there's going to be some nasty weather or questionable weather that we might run into, like icing on the roads, that type of thing. I'm just going to have to play it by ear. And I can say this: if you hear from me, it's probably that I'm just going to live stream those rather than get out on the highway and run the risk of getting in a wreck and creating a lot of scheduling problems for myself and everybody else included. So if you don't hear from me, that you can interpret that I'll be there for class. And I want to also bring your attention to one final thing, and I do appreciate you staying with me. I've had a few of you who've had to take off, about half of you, or several of you. That's okay. You can watch the rest later. I do have virtual office hours today. I have virtual office hours on Friday. I have the links there for you in the announcements. And if you have a question, you can come over. I record them, but I don't post them. And I can try to help you out. When I look at my schedule here, okay, and I see that this week I've scheduled in 15 hours of office hours, both in Shawnee and virtually, I'm not sure how I could be any more accessible to you. And you can send me an email and I respond to them pretty quickly. So I would encourage you, just if you're curious, just try the virtual office hours to see how it works. It's pretty much like this. You just come in and you have a question and I try to answer it. And like I said, I record those, but I do not post them. And so I'm here and I can help you with just about anything other than providing you a signature on the document. And those virtual office hours are indeed there for you. I'm here. And so I hope that you'll just try one just to see what it's like. I think I've had some students last semester who started to use it on a very regular basis because they said, gee, if you're not here, I can get a hold of you in the virtual office hours. I can get my question asked or problem solved. Thank you so much, everybody. I appreciate your time and attention. And for those who've gone on, they'll be able to see the rest of it. Thank you for those of you who stayed. I did eat into a little bit of our time. Take care, everybody, and be safe out there. And hopefully I'll see everybody over there tomorrow.